Hello friends, welcome to our new video. In this video, we wish to solve some question posted on Signal and System group. So let us solve few of the problems mentioned there. The first problem mentioned there is y of n is equals to x of n minus x of n minus 1, right? And the question asked is uh, determine if the system is time variant or time invariant. So first of all, what we need to do is we want to shift x of n with x of n naught, right? So what would be the result? Y of n is equal to x of n minus n naught minus x of n minus n naught minus 1, right? Now first we shifted the input, now we want to shift the output. For example, y is equal to y of n minus n naught. Let's see what would be the result. The result must be y of n minus n naught is equal to x of n minus n naught minus x of n minus n naught minus 1, right? So these two values are same. That means the properties of the system does not change. So this is time invariant system. The second question in that post is that determine whether y of n is equal to 5x of n minus 2 plus 2x of n. Determine whether it's a memory less uh, or dynamic system, right? So the definition for dynamic system is if a system depends on uh, any future or past value, right? So for example, if I want to calculate y of 0 means it, if I wish to compute output at current index, then I need input from past values and one current value, right? So this system is, because it depends on previous input, the time here is y of 0 means in current time, but it needs the values from past. So this is a dynamic system. In the third question in that post is that if for example y of n is equal to 5y of n minus 2 plus 2x of n plus 3x of n minus 1 plus 4x of n plus 1, right? So the question asked is that draw the mathematical, so the block diagram for this. So at one part we have x of n and second we have y of n, right? So one thing is, you can see x of n is multiplied with 2, so we get 2x of n here, right? 2x of n here, and 3x of n minus 1. So how can we achieve it? If we introduce one delay here and then we multiply it with 3, then we get 3x of n minus 1 here, right? So this and this is done, and one is 4x of n plus 1. So what I can do is I can just multiply z. Now z is advancement, right? If I multiply with 4 here, so I would, the resultant summation would be equal to 2x of n plus 3x of n minus 1 and 4x of n plus 1. What we are left with is this value 5x of n minus 2. So if I introduce z inverse here, I will get y of n minus 1, but we need 2 delays, right? So this is z inverse. So the output here is y of n minus 2 and we need to multiply it with 5, right? So multiply by 5 and it, right? So all other questions are very much related to this question. So we stop here and I hope the rest 3 questions would be solved from using this technique. Okay. So I am going to end it here. I hope this would help.